Hello everybody. Today's lesson is going to be about transmutation and the types of radiation that cause it. First thing, transmutation refers to an element of one type transmuting into an element of a different type. Oxygen to nitrogen, gold to silver, different things. Now this cannot be done by chemical reactions as the alchemists tried to do, but it can be done with radiation. And we're going to talk about 4 different types of radiation today. The first is alpha. And when we're reading symbols like this, what you need to know is that A is mass and Z is the number of protons. So if I have some element that has a mass, it has a number of protons, it has a symbol. If it releases an alpha particle, which has a mass of 4 and 2 protons in it, then that first element, its mass will decrease by 4, and its number of protons will also decrease by 2, because they're now part of the alpha particle, which is gone. It's been ejected from the nucleus. Since the number of protons you have defines the atom you are, then the element that you started with is not the element that you ended with in alpha radiation. Its number of protons has gone down by 2. Beta radiation is different. In this case, the mass will stay the same, but the number of protons will go up by 1 as an electron is just ejected from the atom. This electron, as a beta particle, did not start as an electron. It was first a neutron. And that neutron broke apart into a proton and an electron. The proton stays in the nucleus, which is why the number goes up by 1, and the electron is ejected. And this is what is seen with beta radiation. Gamma radiation is very easy. The mass and the proton number do not change, neither does the identity, but very high energy light is emitted as a gamma ray. Finally, a positron, which is for all intents and purposes a positive electron, is a type of antimatter, but you can basically think about it as the opposite of beta decay. In positron decay, a proton decays into a neutron and a positron. And so since that proton is gone, the proton number goes down by 1, and that positron is emitted out of the nucleus. These are the 4 main types of radiation. Now let's take a look at how they impact transmutation. So, when we're reading a symbol like this with a number on top and a number on bottom, just as we had here, the number on top is mass, the number on bottom is the number of protons. And so we can fill this out for alpha, beta, and positron. For alpha, we start at 110, but my mass will go down by 4. And so we're going to end up at 106. For beta and positron decay, there is no change in mass. Now for atomic number, the number of protons, with alpha decay, it goes down by 2. Go down from 47 to 45. Beta decay increases by 1. And positron, we decrease by 1. And now to figure out what elements we've become, we take a look at the periodic table. Here's silver. The first time we did alpha decay, we went down by 2, and we became RH, rhodium. With beta decay, number of protons went up by 1, so we went from silver to cadmium. And then finally, with positron decay, number of protons decreases by 1, silver has become palladium. This same general process can be continued for different elements like sulfur and boron. I'll leave the periodic table up here. Why don't you try on your own? Alright, let's take a look if you were right. First things first, let's do masses and protons. Alpha down by 4, down by 2. Beta, mass stays the same as positron. For beta, protons goes up by 1, positron down by 1. Which means that sulfur released an alpha particle to become silicon, released a beta particle to become chlorine, and a positron to become phosphorus. You can try boron on your own, but let's take a look at this. With this type of nomenclature, all we have is the name and the mass. And that's mainly because the name already tells you the number of protons. Elements are defined by the number of protons. So if you see a setup like this, we're going to follow a slightly different route when answering these questions. First, we're going to just draw a dash. After those dashes are going to go the masses. Well, with alpha radiation, mass goes down by 4, but with beta and positron, it doesn't change. And now we're going to start with chlorine. With alpha radiation, go down by 2, becomes phosphorus. Beta radiation, number of protons increases by 1, we get argon. And positron decreases by 1, sulfur. Let's do one more. Sodium again, hyphen 20, that 20 is the mass. For alpha, it goes down by 4, and the rest, it does not change. Sodium is here, element 11. We step back 2 for alpha decay. That gives you fluorine. Go forward 1 for beta, magnesium. And come back 1 for positron, gets you to neon. You should try nitrogen on your own, and I hope this helps with radiation and its effect on elements changing from one type to another. Have a great day.